we are there is names and formulas of the compounds. Why the naming and formulas is important in anything? Like when we study anything, we have the names, right? In biology, if you remember, we did binomial nomenclature. If you remember,
Yeah,
so why the naming is important?
to actually know what stuff to
Hmm.
make it easier for the scientists to
Yeah, for us to understand.
classify.
Yeah, to identify, to classify, because every species have some special characteristics. And if if you have, for example, some chemicals in powder form,
Mhm.
let's say four chemicals in powder form, and all the four are white in color, but they all are
Mm.
different. So how will you identify if you don't mention the labels on the bottle? Then it will be
Yeah,
difficult for you, right? So that's why
yes.
we have names of the compounds, we have formulas of the compounds, so that we can identify, so that it is easy for us to understand the things.
Hmm.
Okay. Now they have mentioned many compounds contain just two elements, like the compound, how compound is formed by the combination of two elements, right? At least
Two
two
elements,
elements.
yes.
Yeah.
Yeah.
So if you know which element they are, you can usually name the compound. Okay, now how they are telling us how can we name? First thing, when the compound contain a metal and non-metal. Can you tell me which type of bonding is this metal and non-metal?
uh Metal and non-metal, it's what's it called, it's ionic
Yeah, it is
compound.
ionic bonding because
Yeah.
yes, metals belong to group number one and group number two, and non-metals
Yes,
the group
because
seven and group
negatively
six.
and
Yes, yes.
non-metals aren't.
So okay, when you have an ionic compound, you remember I told you that metal name remains same. Like for example, we have potassium, we have sodium chloride. Let's say we have sodium chloride. In this sodium is metal, right? Sodium is metal.
Yes.
So sodium will remain sodium. Its name will not change, right?
Yeah.
But the negative part, the anionic part, how you get this? You get this from the chlorine, right? So the original
Yes.
name is chlorine in the periodic table, but when you combine it, the non-metal name will change to IDE in the end, right? So it will be chloride. Are you
Yes.
getting this? Otherwise, it
Yeah.
was chlorine gas. It was from the chlorine gas. But now, since there is a combination of metal and non-metal, now we will change the name of the anion, okay, the non-metal. So the
Hmm.
first thing they are telling us, if the compound is ionic, it means you have metal and non-metal. In this, the name of the metal, firstly we will write the name of metal, right? We always write sodium chloride. We don't write chloride sodium, right?
Yeah.
Sodium chloride. The first place will be of the metal name, right? And
Hmm.
then the name of the non-metal, but ending with IDE.
Yeah.
Okay. Then the name of the non-metal with IDE, chloride. Sodium
Hmm.
chloride, like for example, we have, if you know this, mm, FeS. What is this? Fe is iron, right?
Hmm.
Iron is a metal. So its name will remain same. Iron will be pronounced similar like this. But you see, S is for sulfur, right? S is sulfur.
Yeah.
So in this bonding, what we will change? The sulfur will be changed to IDE, sulfide,
Mhm.
right?
Sulfite, yeah.
So it will be iron sulfide, right?
Yeah.
Iron sulfide.
Sulfite.
Yes. Similarly, if I have this one, what will be the name of this? What is this? The first one, K.
uh what's it called, potassium.
Yeah, this is potassium. It will
Potassium
remain same.
chlor
Yes. Yes.
Yeah.
What is this?
Chloride.
Chloride. Right. Otherwise, if you have just like this chlorine, so this will be chlorine gas, right?
Yeah.
If you have two atoms of chlorine, you will say the two atoms of chlorine. You will only say it chloride when it is bonded to a metal, right? When it is bonded to a metal. Then
Yeah.
we will change the name of the non-metal. The non-metal name change will to the IDE, right? Clear?
Hmm.
Okay.
Yeah.
The second thing they are telling us that when the compound is made of two non-metals. Okay, now if you have two non-metals, for example, okay, tell me which type of bonding is this? When you
Two
have two
non-metals,
non-metals.
it's a covalent bonding.
Yeah, it's a covalent bonding. Can you give me an example? Covalent bonding.
Like, okay, so basically, like, you can say, like hydrogen and chlorine.
Yes.
Yeah,
HCl.
like,
HCl, right?
yeah, it's, yeah, like you, what's it called, share the electrons.
Yeah, hydrogen and chlorine will share the electron. There will be the sharing of the electrons among hydrogen and chlorine.
Yeah,
Okay. If we have
hydrogen will get two, and chlorine will make the octets.
no hydrogen will not yeah, oh hydrogen duplet. You are
Yeah,
saying duplet,
yeah,
yes.
it will get duplet, and chlorine will get the octets.
Octet. Yes, and hydrogen is sharing one while chlorine has seven in the valential, right? So that's why
Yes.
there is. Okay, if you have hydrogen chloride, how you will name it hydrogen? The first name will always be the same. The first atom is
Hmm.
hydrogen, so it will be written
Yeah,
as hydrogen. Okay. The
yeah.
second one, the second non-metal will be changed to IDE. Okay, always second will change. Second metal, whatever is this, maybe if there is metal or there is non, there will be no metal. Second species non-metal, right? If you see the first one in ionic compound, in this the second species was non-metal, right?
Hmm.
The chlorine, sulfur, oxide, they all are non-metal. So if you have two elements and they are combined with each other, the first element, whatever the first element is, second element they are mentioning that second element will be non-metal, right? Like this,
Yeah.
like this. So the first element, whatever the first element is, it remains same. Its name will not change. Like this, hydrogen, hydrogen, and the second species is chlorine, so its name will change to chloride, right? Its name will change
Hmm.
to chloride. Clear?
Yeah.
Okay. So when the compound is made of two nonmetals, they have mentioned if one is hydrogen, give it name first. Okay, hydrogen will be given the first name. Otherwise, name the one with lower group number first. Okay, this is very important. If you don't have hydrogen and you have, for example, you have taken two nonmetals. Let's say you have taken, uh, yeah, you have taken this one, carbon dioxide, right? You have taken carbon dioxide. They are saying,
Hmm.
firstly, you know, this is what is this? Is this ionic bonding or is this covalent bonding? What is this?
Carbon, and it's ionic bonding.
Is this ionic? Think
No, no,
about it.
covalent, two
Yeah,
nonmetals.
carbon belongs to group number four, right? Carbon belongs
Yeah.
to group number four. It will share electrons with the oxygen. So we have this carbon dioxide. Now they have mentioned that you don't, you see, there is no hydrogen. They mentioned that if you have metal and non-metal, sorry, two non-metals like the HCl, right? HCl. There were two non-metals. In that, they mentioned that you will give the first name to hydrogen. Okay, clear? If you have hydrogen in any species like HF, HCl, HBr, in all these, which species will get the first name? Hydrogen. Hydrogen will
Yeah.
get the first name. Okay, they have mentioned if you have two, if you have a compound, if you have a covalent compound which is formed by two non-metals, and those among those two non-metals
Hmm?
one is hydrogen and the other
Before
one,
she step partners.
sorry,
Nothing, nothing.
are you saying something?
Mm-mm.
Okay, uh these two are there is a combination of two non-metals, right? So if you have a combination of two non-metals, it means this is a covalent bonding. And if this is a covalent bonding, you have to check, is there hydrogen? Okay, if you see hydrogen is there, then you will name hydrogen first. Okay, remember this thing. Hydrogen will be given the first name, like hydrogen,
Mhm.
and the second name will be given to this, the second species, that is bromine. Okay, so bromine is an second non-metal. Can we write hydrogen bromine, or what will we do with this? We will change it or not?
Yes.
What will be the name now? Hydrogen.
Hydrogen, bromine.
No, bromine
Bromide,
is same.
bromide.
Yeah, bromide.
Says.
Okay. And remember, the second species, it will be written with small letter. Okay. First species will be written with capital letter. Second will the with the small letter. Clear?
Hmm.
This
Yeah.
was the case of hydrogen fluoride or hydrogen HCl. Like if you have a covalent compound which is formed by hydrogen and other non-metal. You know hydrogen is non-metal, right? So
Yeah.
two non-metals are combining. That is a covalent bond. Among those two non-metals, one is hydrogen. Then we will give the first name to the hydrogen. Okay, hydrogen will always get the first name if you have such a scenario. Otherwise, if you have two non-metals and like this, the carbon, this one, these are two non-metals, right?
Hmm.
So which species should be given the first name
So like
among carbon and oxygen? Which species,
uh
which element should be given the first name?
carbon,
Why?
because it's in the like it's in group 4, but the oxygen is in group
Six.
in 6. Yeah.
Yeah. So the lower group number will be given the first
Always
name.
comes first.
Yeah.
Yeah.
So carbon dioxide. Okay. Right. We will write it like this. Okay. And
Hmm.
if we have metal and non-metal, let's like ionic compound in that like this metal and non-metal. Which one will be given the first name?
Which one?
This in this sodium chloride. Which
Yeah.
element will be given the first name?
Sodium, Na.
Why? Why?
Because sodium comes first in the group.
Yeah, this in this we see when you have metal and non-metal, we always write the name of metal first. Okay,
Oh, okay,
we don't
okay.
see the
So
group.
in a covalent bond, if like they ask why do we write it, we always say metal first and non-metals.
No, ionic bonding. This is ionic bonding,
Yeah, sorry,
NaCl.
ionic, ionic.
Yes.
Yeah.
In covalent bonding, we have two scenarios, right? In covalent
Hmm.
bonding, maybe the bonding is hydrogen is non-metal as well. So the bonding may be hydrogen with other non-metal. So in this case, you will give the name hydrogen. Hydrogen will be written in the first name. Okay. And if you have two non-metals, this type of covalent bonding, then we will see which group comes first. Okay, which one is lower group
Yeah.
number? Which one has lower group number? So carbon belongs to group number 4, and oxygen belongs to group number 6. So definitely we know that carbon will come at first place, right? We don't say
Hmm.
dioxide carbon. This is not the correct name. We always say carbon dioxide. Why is this so? Because carbon belongs to group number 4 and oxygen belongs to group number 6. We always
Hmm.
write the name of the species which comes first, right? Which comes in the lower group. Are you clear with these two rules of
Yeah.
naming? Okay. Now they have mentioned about the formulas of the compound. We have done this like in the covalent bonding, if you remember that how these species are combined. If you remember, this
Yeah.
one, the molecular compound. Can you tell me how water will make bond? If we want to make uh, a structure of this, how can we make it structure? Like if I
Uh,
say that you have water, draw its structure.
yeah.
So what will you do?
We will put hydrogen in the middle and then like two oxygen,
What
so
is the first step of making bonds?
H2O. So
Hmm. What is
yeah.
the first step?
So like you have to do,
Hmm.
what's it called? Like to do like make the oxygen in the middle, and then like
First
two
thing is
hydrogens.
first thing
Yeah.
is to write electronic configuration, right? Otherwise, we don't
Oh yeah,
know.
yeah.
We can't understand how many electrons are there, how many electrons should be making bond, right? So first thing, always
Hmm.
you remember when we were doing this bonding,
Yes, yes.
covalent bonding. So I always suggested you that whatever the compound you have to write its electronic configuration first, right? Like this, the water.
Yeah,
In the water, we have what we have. We have hydrogen and oxygen, right?
yeah.
And in which group hydrogen belongs to which group?
Group 1 and oxygen to group 6.
Yeah. So what will be the electronic configuration?
For hydrogen, it will be 1, and oxygen, it will be 2, 6.
Yeah, because
No,
I
sorry.
oxygen. You're right. Oxygen is
Uh,
8. Total,
yeah.
its atomic number is 8. So in the first
Oh,
cell
okay,
there will
okay.
be 2, In the second shell, there will be six. So it means
Hmm.
what is the vacancy? What should be done? If you see this configuration, what should be done? Hydrogen is one, oxygen has six. What is the possibility for oxygen? Is it possible for oxygen to lose six electrons?
No, to gain 2 electrons.
Yeah, this is the best possibility. No one gives their more electron. It's not the case. Like you can't give your more money to your friends, right? You will only give
Mhm.
$1 or $2.
Yeah.
Okay. And what about hydrogen? What is the best
Hydrogen,
possibility?
it can gain 2.
It can gain, yeah, it can share
It,
one electron, right?
yeah, we'll share one, sorry.
So if we have, hmm,
Yeah, share one, so make it 2 for the duplet.
so we have, okay, there is, water. In water, there are two hydrogen and there is one oxygen. Why there is one oxygen?
Hmm.
Why we are not taking two oxygens?
Because then maybe because the hydrogen will become like 3. It'll be
In
like
that, no, there is hydrogen peroxide, H2O2. You know that?
oh yeah, perox. Okay, okay.
Hmm. We can do that. But
Hmm.
in water, I'm asking in water. Why we
Yeah.
have one oxygen in water? See this diagram, see this bonding.
Hmm.
Why we have one
Yeah.
oxygen? And tell me.
Um.
You see, six electrons are there, right? Oxygen
Yeah.
has six electrons in the valence shell, right? And it needs,
Because
hmm,
yeah, it needs 2 to gain.
yeah. So one hydrogen will give one hydrogen will share one,
Yes.
and the other
Yeah.
hydrogen will share the other one, right? So this is the
Yeah.
bonding structure, right, of the covalent structure.
Yeah.
So
Yeah.
this they have mentioned here that a molecular compound, the molecules on the right are drawn like this. You see, oxygen is in the center, and two hydrogens are shared. So how come we know about this? By electronic configuration. That is the most important concept, right? That's why they have mentioned it in
Hmm.
the chapter number 2, that you must know the electronic configuration. Otherwise, it is not possible for us to make bonds.
Hmm.
We can't predict which one will gain one electron, which one will lose electron, or which species is sharing electron. This all depends on their electronic configuration. And if we
Hmm.
are writing electronic configuration, we must know what are their atomic numbers, right? Because otherwise you
Yeah.
can't write. If you don't know the atomic number of oxygen, then how can you write about it? Hmm?
Yeah. True.
Is
True.
this is not possible, right? So
Yeah.
the first thing, if we start from the base, first thing is to check in the periodic table the atomic number of that species. Second thing, write the electronic configuration of that species. Then see what will happen. When you are done with writing the electronic configuration, then you get the idea whether there will be sharing or whether there will be transfer of electrons. Like, in ionic compound, if you see this, there is ionic compound
Hmm.
over here. Now, this one. In the ionic compound, we have discussed that ionic compounds are formed by losing electron, right? The metal will lose and the non-metal will gain,
Okay.
right? You
Yeah.
remember this? The potassium, like if we have potassium and bromine, the potassium will lose electron. If you
Yeah.
see this, the potassium belongs to it. Its atomic number is 19, 2881, right? This is
Yes.
2881. So it has one electron in the valence shell. What is the best possibility for potassium? To gain seven electrons or to lose one electron?
To
See this.
gain 7. No.
Can it gain seven?
No. 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 It has to lose one, so it
It,
can.
it
Yeah.
has
It's
to,
easy.
yeah. So potassium is a metal. It will lose one electron. How come we know about this? By writing the electronic configuration, right?
Hmm.
Otherwise,
Yeah.
if you see just potassium in the periodic table, you can't predict what is happening. We have to write the electronic configuration, right?
Hmm.
Then
Yeah.
there is bromine, and bromine is it metal or non-metal? Bromine,
Non-metal.
yes, bromine is a non-metal. It has 35, right? Its atomic number is 35, so this will be 2, 8, 18, and 7, right? You know the configuration, right? How
Yeah.
to write the electronic configuration, right? Okay, now can you tell me there are seven electrons. What is the best possibility for bromine?
Bromine. So it has to gain one.
Yeah, it can gain one. It is the best possibility. So potassium will
Yeah.
lose and bromine will gain. So this is what? This is ionic bonding. Remember, in ionic
Yeah.
bonding, one species loses electron, and that is metal. Always you will see the metal will lose electron because metals have free electrons in them, right? They can
Yeah.
lose electrons. But if we talk about the non-metals, non-metals, they have more electrons in their valence shell. They can't lose them. They always gain electrons. That's why we say them they are
Yeah.
non-metals.
Hmm.
Are you clear with with the difference between ionic compounds and covalent compounds?
Yeah.
That ionic compounds are formed by the transferring of electrons, right? The one species
Hmm.
will lose and the other species will gain. While the covalent bonding, what happens in covalent bonding?
Covalent bonding is
Mhm.
between the like it what's it called mm, like where like the like two non-metals share
Yes,
electrons
two
together. You
non-metals
know,
are
like
sharing. Okay, why they are sharing? Why can't one species lose and the other species gain? Just like in
uh
ionic compound, right? In ionic, one species
yeah
loses and the other species gains,
two, but it like it has like non-metals are in like group 4 or less,
or
so
more, group
it won't
four or
have.
more.
Yeah, sorry, yeah. That's why it needs
Yeah,
like a stable shell, like full outer
yeah.
shell.
They need sharing. They can't.
Yeah.
No species can. The no. Sorry, you will not get any species which will like the non-metals. If there is a non-metal like carbon, it has four electrons. So it is not possible for carbon to lose four electrons,
Hmm.
right?
Yeah.
Um, mm, Okay, I am saying that in covalent compounds, in covalent
Hmm.
compound, they are from the group number four or more, group four, five, six, seven, eight. But
Yeah.
we don't talk about the group eight because group eight is full, right? They don't participate
Yes.
in bonding. They are noble gases. Okay. If we talk
Hmm.
about from group number four to group number seven, they have four, five, six, and seven electrons in their valence shell, right? Respectively.
Hmm.
Like group four has four electrons in the valence shell. Group 5 has how many electrons in the valence shell?
Hmm.
How many electrons are there in the valence shell of group number 5?
5,
Yeah. Group number 6,
6.
group number 7,
It will have 7.
7. So they can't lose, right?
Yeah,
They,
it
they
can
will
lose like
only, yeah,
7 or
they will
6
only
or.
share. That's why in covalent bonding, you don't see any species losing and other species gaining. This is not the case in covalent bonding. The covalent compound always share the electrons, right?
Yeah.
Are you clear with this?
Yeah.
Okay. Are you getting any background noise?
From you, no, no.
Okay. Okay, covalent bonding, yeah, this one. If you remember, there is non-metals. They don't lose electrons. Either they tend to share electrons, right? They will
Hmm.
share like the
Share
carbon carbon.
electrons.
Okay. Always it will be among the non-metals, right? And
Hmm.
like the hydrogens, chlorines, two chlorines, two carbons are combining, two oxygen are combining, or two fluorines are
Yeah.
combining. This we have done in detail in the chapter number 2. Now they are telling us about the formulas. So a molecular compound, if you have this compound, now they are telling us the molecules on the right are drawn in different styles. You see the water, you can draw it like this and you can also draw it like this.
Hmm. Yeah.
This is the same water, but we have different patterns to draw.
Hmm.
Similarly, a molecule of ammonia has one nitrogen and three hydrogens. Can you tell me why is this in the ammonia that we have one nitrogen and three hydrogens?
Oh, maybe because like
Hmm.
ammonia needs like 3 hydrogens. Like ammonia has it's in group
To which,
5, I'm pretty
yeah,
sure.
yeah, it is in the group number 5. So
Yeah, so it
how
needs
many
3
electrons?
to
Yes.
get octets.
Yeah, so it will share the three of the hydrogen. The hydrogen will share its three electron to the ammonia,
Yes.
one by each hydrogen, right?
Yeah.
Okay. The formula for a molecular compound tells you the type and number of each atom, right? It tells you type. What is the type? Which type of bonding is this? Is this covalent bonding or is this ionic?
Um, it's covalent. Both are what's it called? Both are
Mm.
non-metals.
Both are non-metals. What about water?
Water, like
Mm.
water is a non-metal as well, covalent.
Water is a non-metal, right? So a molecule of ammonia. No, so they are saying that this formula tells us two things. First thing, it tells us the type of bonding, right? The covalent bonding. Then it will tells us a number of atoms. How many number of atoms are there in one molecule of ammonia? Can you tell me how many number of atoms are there? Total number of atoms in ammonia.
Uh,
Atoms,
like how
not
many
electrons.
tot?
Yes, atoms.
Uh, it's
Hmm.
wait.
It's very
So like
simple. Hmm.
nitrogen will have what's it called? It's
I'm not talking about electrons. I am talking about atoms. Atoms.
like
Like
three atoms.
one nitrogen atom
Oh,
and
okay,
three.
okay.
Yeah,
Oh, okay. So it will have in in total it will have like four
four.
atoms.
Yeah, four atoms, right? And what about water?
Yeah. Water it will have three.
Yes, it will have three atoms, right? If they ask you atoms, it means you have to mention this, that oxygen atom, two hydrogen atom. They are not talking about
Yeah.
electrons. They will not ask you how many electrons are there. You must know electrons just for bonding, like you must know the electrons to write the electronic configuration. Otherwise, you don't need that. In this, they can ask you what type of bonding is this and how many number of atoms are there. Simple. In ammonia, there are four atoms. In hydrogen, there are three atoms, right? Okay, we have some other
Yeah.
examples like SiO2, silicon oxide.
Mm-hmm.
How many atoms are there?
Silic. Uh. So wait.
It is written here, silicon oxide, this one.
Yeah. SiO. So one silicon atom and two oxygen atoms.
So in total, we have
So three atoms.
three atoms, right? Good. Okay. So this was about the formula of the compound. The first one is molecular compound. Now they are telling us about the ionic compound. This you already know. Now you have to tell me what is this? What they have mentioned here. Read this and tell me in your own words from here.
Okay.
Ionic compound.
Okay, an ionic compound, the structure of the ionic compound potassium iodine is shown on the right in two different slides. Each lattice has one K plus ion for every I minus ion. So the formula for potassium iodine is Ki. The formula for an ionic compound tells you their type and ratio of the ions in the compound.
What they are telling us. Okay, this is not plus
So
and this is not minus. You will
yeah,
say this is potassium ion. Whenever you have plus charge, it means this is
mhm,
ion, right? So this is potassium ion. And this
yes,
is iodide ion. Okay, this
yeah,
is not iodine. When iodine gets a charge, when we have discussed when anions get charged, their name is changed, right? This is anion.
yes.
Iodine is
Yeah, it
anion.
will be a cation. Yeah,
Cation is
and
potassium.
ions is cat. Yeah,
Anions, cations are this one. Metals. Metals are cations, and non-metals.
yeah,
Most of the non-metals are anions. So this will be iodide ion. You will not say I negative. Clear?
mhm,
It does not
yeah.
sound good. Okay. What you are telling about this? What is this?
No, no, just
Yeah,
like what's it
you
called?
read
Like
this.
for K.
What you
Yeah,
understand by this?
yeah. I like it was showing like each lattice for has like a positive charge to potassium and like like for every positive charge to
It
potassium,
will be
there's like
bond with
every negative charged ion.
ion, right? If you
Yeah,
see
so
this,
it's bonding together, it's sharing.
yes,
No, it's
not
bonding
sharing.
with.
Yeah, there is
Yeah,
ionic bonding. There is always one
yeah,
species losing, another is gaining. They have mentioned
yes,
that these one, I think this is purple color, maybe this is purple color. So these bigger ones are iodine, right? And the smaller ones, these blue
yes,
ones are potassium. So if you
yeah,
see one potassium in front of this potassium over here, there is iodine, right? Then after iodine
hmm,
there is potassium. Then after potassium there is
yeah,
iodine. Then after iodine there is potassium, right? Then after potassium there is iodine.
yes,
Then this one. This is a repetition of potassium iodine, potassium iodine, potassium iodide. Okay, one
Mm-hmm.
ion is of potassium, the other ion is of iodide. So this happens
Mm-hmm.
in the
So it will be so what's it called? If silicon is like it has four in the electron shell, and no, I mean sorry, what's it called? Potassium has
one
no,
electron in the valence shell,
yeah, yes, it will have one electron in the
and
valence.
iodine needs one,
Uh,
right? Iodine
yes.
belongs to group number 7. It has 7 electrons in the valence shell. It needs one. So what will happen? The potassium will lose, iodine will gain. Then this potassium will lose, iodine will gain. And there is a bonding, right? This whole bonding.
Mm-hmm.
This is a crystal structure. You see, this is a crystalline lattice, a proper arrangement.
Yeah.
So they have mentioned that ionic compounds, they form a proper lattice. Clear?
Mm-hmm.
This
Yeah.
one. Okay, so the general formula for this will be potassium iodide. You can't write, like, for example, there are 100 molecules, 100 atoms of potassium. So you will not write K 100, then iodine 100. We don't write it like this. We only write the
Mm-hmm.
simplest formula that in this you have atoms of potassium and you have atoms of iodine. This happens in
Mm-hmm.
ionic compound. Okay, remember this thing. Otherwise, in
Yeah.
molecular compounds, you have to mention the proper molecule and you have to mention
Mm-hmm.
how many atoms are there. Are you getting this?
Yeah.
The difference between a molecular compound and ionic compound. This can be asked.
Mm-hmm.
If you have any
Yeah.
confusion, you can ask.
No, no.
In the last two lines, they have mentioned that the formula of ionic compounds tell you type and ratio of the ions. Can you tell me what does it mean?
Uh, like the formula for an ionic compound tells you the type of ratio, the ions and the maybe it shows like an ionic compound you have to like lose like um
Firstly, ionic
like
compound. What is the type? Type means is this ionic or is this covalent? What type of bonding is
it,
this?
this is a ionic.
Ionic bonding, right? Now, what
Yeah.
about ratio? Ratio means
It
it
shows
is
like how
telling,
much are losing and how much are getting.
yeah, ratio means not it is not the ratio of the electrons, it is the ratio of how many potassium and how many hydrogen are there. Let's say potassium are 100 and iodine are also 100. So if you want to
Yeah.
get the simplest ratio, what would be the simplest ratio? Isn't it 1:1,
Hmm.
right? So that's why
Yeah.
we write potassium iodide like this. Clear? Always remember, the atoms will be same in this lattice. If we have 100 potassium, we will have 100 iodines, right? Because you see, one iodine is combining with the other potassium, then potassium with iodine. And this is a regular structure. So if you have a regular structure, both the atoms, both the anion and cation will be same in number. If you have
Yeah.
200 potassium, then you will have 200 iodide ions. If you have 300 potassium ions, then you will have 300 iodide ions. Okay, and the simplest ratio will be 1:1, right? Simple.
Yeah.
Are you clear with this?
Yes. Yes.
Okay. Now there is a table finding a formula using valency. How can we find the formula using valency? This is very important table. Can you tell me about this? What is this like? What is the general idea about this?
Mm.
Hmm.
Like we just explained it. That's it.
No, but what
So
what
like
we
it shows.
hmm.
Yeah, it shows basically like group one loses like electrons and it shows like how like what group loses electron shares or gains electron and like but it shows like how much valence shell it has.
Yes, valency electrons,
uh,
not
yeah,
shells. Valence
yeah,
shell is
valency
always
of
one.
the element.
Yeah,
Yeah, and
valence
it shows
electron.
like what can it form with. It gives examples of it.
Is basically in this table they are telling us that how by the help of valency we can make bonds.
Hmm.
Valency helps us to make bond. For example, if we talk about the group number one, what is the valency of
Yeah.
group number one? The elements of group
Group,
number one. What is their
it will be
valency?
one.
One electron. It
One.
means they have one electron. So what
Yes.
can they do? What can they do? What are the possibilities of group number one atoms?
To gain one.
Yeah, they can make bond with one other species, right? Only one other atom.
Yes.
Okay, so like this, sodium. Sodium belongs to group number one. So it will lose one electron, and on the same time, the chlorine, one chlorine, okay, one atom of chlorine will gain that one electron, because chlorine belongs to group number 7. It has 7 electrons in it. So that is why it can gain one electron, right? So this group number is telling us that group 1 elements can only make one bond, right?
Mm-hmm.
Like the sodium is
Yeah.
making one bond with chlorine. Can you give me any other example of this?
Uh,
Like group number 1
oh,
atoms with any other non-metal.
hydrogen and chlorine.
Hydrogen and chlorine are not. Hydrogen belongs to group number 1. Okay. Yes, hydrogen belongs to group number 1, and chlorine belongs to group number 7. So you see, hydrogen
Yeah.
is making one bond with chlorine. It is not. You don't see HCl2. Have you ever seen
Mm-hmm.
this like this? Have
Mm-hmm.
you ever seen this HCl2?
Mm-hmm.
This is not possible. Why? Because hydrogen can only make one bond with chlorine. Are you getting this? Hydrogen
Yeah.
belongs to group number 1. It can only make one bond with chlorine. Similarly, sodium belongs to group number 1. It can make only bond with one bond with chlorine. So group 1 elements, they can only make one bond, right?
Yeah.
With the other atom. Okay, what about the group number 2?
Group number two, it can make like with like group number six.
No, I am not talking about which group. I am asking
Uh,
how many bonds they can make. How many
how
bonds they
many?
can. Just
They
like
can
group
make
number 1. The group number 1, they have
two.
one electron. Yeah, they can make two bonds. If you see this
Mhm,
example, magnesium chloride, you see magnesium chloride is like this. You have magnesium in the center. There is one
mhm.
chlorine and there is other chlorine. So this magnesium,
Yeah.
it belongs to group number 2, right? So it is
Yes.
making two bonds, one with this chlorine and one with this chlorine, right?
Hmm.
Are you getting this?
Yeah.
That the
Yeah.
valency tells us how many bonds a species can make. I am repeating
Hmm.
it again. That first thing is, when we have different groups. In different groups, we have arranged the atoms. These elements have valence electrons. Group number 1 has one electron in the valence shell, right? So it can only make
Yeah.
one bond with the any other species. That can be any other
Yeah.
non-metal. Similarly, group number 2, they have two electrons in the valence shell and they can make two bonds, right?
2 points. Yeah.
They can make two bonds. Okay. What about the group number 3?
It can make 3 bonds.
Yeah, it has, first thing is it has three electrons. It has three electrons. That's why it can make three bonds. If you see this over here, I gave you the examples of like this aluminum. You see,
Hmm.
aluminum has, okay, where is its number?